Assalamualaikum and salam sejahtera. Today we are going to learn chapter 10 carboxylic acid and its derivative. For introduction, what we're going to learn is about general formula, IUPAC nomenclature and physical properties. And for physical properties, we're going to cover boiling points, solubility and acidity. Alright. Our learning outcome for today for 10.1 Introduction to Carboxylic Acids. A. Write the general formula of carboxylic acid. The structure of carboxylic acid is R C double bond O OH, where R is alkyl group, while AR C double bond O OH, where AR refer to aryl, or here also can be replaced with hydrogen. Functional group for carboxylic acid is carboxyl group. For learning outcome 10.2, nomenclature of carboxylic acids. A. Draw structures and name the carboxyl compounds according to the IUPAC nomenclature, where parent chain is equal or less than 10 carbon. B. Give common name with parent chain less or equal than 5 carbon. IUPAC nomenclature. The longest chain must contain the carboxyl group. The carboxyl group is at the terminal. Therefore, the carbon of the carboxyl group is not numbered. If one COOH, carboxyl group is at one end. If 2 COOH group, carboxyl group are at both ends. Name the compound as alkane, drop E in alkane, and add oic acid, example, methane, become methanoic acid. Now try name this compound. We have C double bond O OH. Means here is carboxyl group. It will be parent. So, carbon here will start as number 1. 1, 2, 3, 4 and 5. So, the longest continuous chain here has 5 carbon. So, if alkane, 5 carbon will be pentane. So, because it has carboxyl group, the name will become pentanoic acid. At carbon number 4, we have bromine substituent, and at carbon number 3, we have methyl substituent. So, name of this compound is 4-bromo 3-methyl pentanoic acid. Alright. Refer to example number 2. Here, we have carboxyl group and also carbon-carbon double bond functional group. Alright. Remember, carboxyl group going to be parent. So, here will be carbon number 1, 2, 3, 4, 5 and 6. Carbon number 6 can be here or here. So, position of carbon double bond is at carbon number 3. And at carbon number 5, we have methyl. So, name of this compound is 5-methyl 3-hexanoic acid. Alright. If there is 2 COOH group, the compounds will be named as alkane dioic acid. Example, ethane dioic acid, propane dioic acid, and the others. Look at this example. We have carboxyl group at the both ends. So, name of this compound is, because the longest continuous chain has 5 carbon, 1, 2, 3, 4 and 5 carbon. So, name of this compound is pentane dioic acid. When R is aryl group, the parent name is benzoic acid. So, if carboxyl group bonded to benzene, the name will be benzoic acid. Okay, and at carbon number 4, okay, start from here, 1, 2, 3, 4. Okay, we have chlorine substituent as substituent, so the name is 4-chlorobenzoic acid. Alright, an aromatic dicarboxylic acid is named as 1X, where X refer kepada position of substituent benzene dicarboxylic acid. Okay, example, we have carboxyl group at carbon number 1, 2, 3. So, position of carboxyl at carbon number 1 and carbon number 3. So, name of this compound is 1,3-benzene dicarboxylic acid. Di refer dua carboxyl group. Alright, and refer to this example, we have carboxyl group at carbon number 1 and carbon number 4. And at carbon number 2, we have isopropyl group. So, name of this compound is 2-isopropyl 1,4-benzene dicarboxylic acid. A cyclic carboxylic acid is named as cycloalkane carboxylic acid. The C atom, which is attached to COOH group, is numbered as carbon 1. Okay, if we refer to this example, COOH group or carboxyl group bonded to cyclopentane. So, name of this compound is cyclopentane carboxylic acid. A cyclic dicarboxylic acid is named as 1X, cycloalkane dicarboxylic acid. Example, we have 2 carboxyl group attached at position 1 and 2. So, name of this compound is 1,2-cyclohexane dicarboxylic acid. If we refer to other example, we have carboxyl group at position 1 and 2. So, chlorine substituent will be at position 1, 2, 3, 4. So, chlorine at position number 4. So, name of this compound is 4-chloro-1,2-cyclohexane dicarboxylic acid. When a compound contains a carboxyl group and other functional groups, the priority is given to the carboxylic acid as the parent. Example, we have carboxyl group and carbon-carbon double bond. So, priority is given to carboxylic acid. Alright, so name of this compound, okay, carboxyl group will be, carbon here will be carbon number 1. So, this carbon going to be number 2, number 3. So, at carbon number 3, we have methyl. At carbon number 2, we have carbon-carbon double bond. So, name of this compound is 3-methyl-2-cyclohexene carboxylic acid. For 10.3, we are going to discuss physical properties of carboxylic acid. The learning outcome is A. Explain the physical properties. 1. Boiling point. 2. Solubility in water. B. Explain the acidity of carboxylic acid in comparison with alcohol and phenol. And 2. Halogenated carboxylic acid based on number of halogens and position of halogens. Physical properties, boiling point. The boiling point of carboxylic acid is higher than an alcohol, a ketone, or an aldehyde. Remember, with molar mass or relative molecular mass that almost the same, because the carboxylic acid can form stable hydrogen bonded dimer between molecule. Molecule in dimers are arranged closely packed. Therefore, the hydrogen bonds are relatively strong. High energy is needed to overcome the intermolecular forces and will cause the boiling point of carboxylic acid become highest. Okay. The structure shows the two hydrogen bonds per molecule formed. The geometry of the carboxyl group allows for the formation of two hydrogen bonds per molecule are known to exist predominantly as dimers. Okay, ini kita boleh nampak, okay, dalam satu molekul carboxylic acid, okay, boleh buat dua hydrogen bond per molekul. Okay, yang ini yang kita panggil dimer. Okay. Physical properties or solubility, carboxylic acid are soluble in water due to the formation of hydrogen bond between the water molecule and carboxylic acid molecule. Okay, so kalau kita nak discuss solubility in water, kita kena mention carboxylic acid itu soluble in water because can form hydrogen bond with water molecule. Okay, so kita lihat kat sini, structure carboxylic acid, dia ada C double bond O, OH. So this part can form hydrogen bond with water molecule. H bonded to O, interaction with O in water molecule. Okay, this part pun ada hydrogen bond with water molecule. This part pun ada hydrogen bond with water molecule. And dekat sini pun kalau kita letak water molecule pun boleh ada hydrogen bond with water molecule. So that's why carboxylic acid soluble in water molecule. Okay. The solubility of carboxylic acid in water is almost the same as alcohol. Kenapa? Kenapa carboxylic acid dan juga alkohol tu dua-duanya soluble in water? Sebab alkohol pun ada OH group juga. So samalah, boleh form hydrogen bond with water molecule. Aliphatic carboxylic acid with carbon larger than 5 are insoluble in water. Ini kenapa pula? Kenapa pula kalau ada karbon banyak insoluble in water? Okay, sebab bila bilangan karbon banyak, maksudnya alkyl group dia besar. Alkyl group itu refer kepada hydrophobic area. Okay, inilah R kat sinilah. Kalau carboxylic acid ni ada bilangan karbon lebih daripada 5, so carboxylic acid itu, walaupun kita tahu carboxylic acid ni boleh form hydrogen bond with water molecule, okay, disebabkan hydrophobic area yang besar ni, okay, jadi dia akan mempengaruhi solubility of carboxylic acid. Alright. Aromatic carboxylic acid are slightly soluble in water. Aromatic slightly soluble, larut tapi larut sikit saja. Kenapa pula? Okay, due to the huge aromatic ring. Kita tahu aromatic ring tu pun sebenarnya alkyl juga. Okay, tapi kita panggil alkyl kan? Aryl kan? Okay, dicarboxylic acid are relatively more soluble since more hydrogen bonds are formed. Okay, kalau ada dicarboxylic acid, maksudnya dalam satu molekul tu ada dua carboxyl group. Okay, tak kira lah dekat carboxyl group, memanglah kena dekat both ends lah kan? Hujung dengan hujung. Okay, asal ada saja dicarboxylic acid, so maksudnya lebih banyak hydrogen bond with water molecule they can form, so more soluble in water. Okay, ini diberi contoh lah descending order of solubility. Okay, so kita lihat kat sini molekul A. Molekul A ni, ada dua carboxyl group. So ini yang kita panggil dicarboxylic acid tadi. Okay, dicarboxylic acid sebab dia ada dua carboxyl group. So dekat sini boleh form more hydrogen bond with water molecule lah, this part. Okay, so more soluble lah kat sini. Okay, compound B carboxylic acid juga, tapi hanya ada satu saja carboxyl group. So kalau compare dengan A, B ni kuranglah sikit larut dia compare to A. Okay, compound C pula. Compound C sama juga, ada satu je carboxyl group, tapi kita lihat pula dia punya bilangan karbon. Okay, compound C ni ada 1, 2, 3, 4, 5 karbon. So maksudnya bilangan karbon lagi banyak daripada compound B. Compound B cuma ada 1, 2, 3, 4 karbon saja. Okay, so bila bilangan alkyl group ini lagi besar, okay, hydrophobic area dia bertambah. ni hydrophobic area bertambah. So, bila hydrophobic area tinggi, okay, dia akan reduce the solubility of carboxylic acid in water molecule. Compound D pula. Compound D ni slightly soluble saja. Okay, sebab apa? Sebab aromatic carboxylic acid. Okay, ini contoh aromatic carboxylic acid lah. Okay, jadi bila ada huge aromatic ring ni, dia akan mempengaruhi solubility of carboxylic acid in water. Alright. Macam mana pula solubility in non-polar solvent? Okay, carboxylic acid are soluble in non-polar solvent such as benzene. Okay, tadi dalam water, sekarang ni dalam non-polar solvent seperti benzene. Okay, larut juga. Sebab apa? Due to the van der Waals forces between the benzene and alkyl group of carboxylic acid. Okay, so selain daripada boleh buat hydrogen bond with water molecule, okay, ni carboxylic acid dia ada R kan? Ni satu molekul carboxylic acid. Ini silap. Okay, ni ya. Ni satu molekul carboxylic acid ini. Okay, dia ada R. Okay, ada alkyl group kat sini. So, R ini boleh form van der Waals forces with organic solvent ataupun non-polar solvent. Okay, so kat sini dia boleh form van der Waals forces. Jadi carboxylic acid ini larut juga dalam non-polar solvent seperti benzene. Alright. Boleh? Okay. Okay, next kita lihat pula physical properties of carboxylic acid. Okay, yang berikutnya iaitu acidity of carboxylic acid. Okay, carboxylic acid ni seperti yang kita faham dan sedia maklum adalah weak acid. Okay, semester 1 dulu kita dah belajar dah strong acid tu siapa. Kalau strong acid maksudnya compound which completely dissociate in water. Okay, dia akan tercerai 100%. Tapi carboxylic acid ni dia masuk dalam kategori weak acid. Okay, tetapi okay, among antara carboxylic acid, phenol and alcohol, okay, carboxylic acid itu most acidic. Okay, kenapa? Okay, kenapa carboxylic acid itu paling berasid compared to phenol dan juga compared to alcohol? Okay, kita lihat kat sini. The acidity of carboxylic acid is influenced by resonance effect. Okay, yang pertama. Yang kedua, inductive effect. So, kita akan lihat apa maksud resonance effect dan juga inductive effect. Alright. Resonance effect, okay, ada dua. Cuba kita lihat kat sini. Okay. Ini carboxylate ion. Carboxylate ion dalam carboxylic acid lah. Okay, ini phenoxide ion. So, phenoxide ion. Phenoxide ion ni terhasil daripada phenol. Alright. So, kita lihat acidity of carboxylic acid. Okay. Carboxylic acid is more acidic due to the resonance stabilization of carboxylate ion. Okay. So, kita lihat macam mana tu carboxylate ion. Carboxylate ion ini ikut diagram ini. Ikut gambar ni. Ini carboxylate ion. Okay, carboxylate ion ini terhasil apabila carboxylic acid dissociate in water. Okay, disebabkan carboxylic acid ini termasuk dalam golongan weak acid, so dia akan hanya partially dissociate sahaja in water. Okay, and will produce carboxylate ion. Okay, tetapi carboxylate ion yang terhasil ini stable. Okay, stable. Okay, macam mana boleh jadi stable? Because the electrons in carboxylate ion are delocalized between two oxygen atoms. Macam mana tu? Okay, ini carboxylate ion. So, carboxylate ion tu negative charge ini dekat oxygen atom yang biru, dekat oxygen yang biru ni. Okay, so kalau kita lihat pula gambar yang kedua ni, okay, kita lihat gambar yang kedua ni, oxygen atom negative charge ni. Okay, negative charge ni boleh bergerak dekat oksigen yang atas. Okay, ini nak menunjukkan yang the electrons in carboxylate ion ini can be delocalized between two oxygen atoms. Ini simbol resonance. Alright. Faham? So, carboxylate ion ni dia jadi stable lah. Jadi, stable. Okay, so that's why carboxylic acid become more acidic. Alright. And then another factor is the C double bond O group in carboxylic acid is electron withdrawing group. Ini adalah EWG group, electron withdrawing group, which reduce the electron density of OH. OH kat mana? Dekat sini. OH yang kat sini ni. So, density of electron dekat OH ini rendah. Therefore, the OH bond become weaker. So, OH bond ini become weaker. So, H plus easily donated. Okay, easily donated to water. And carboxylic acid is more acidic than phenol. Okay, bila H plus donated to water, okay, and akan form H3O plus. So, that's why kita bagi tahu carboxylic acid ini more acidic than phenol. Alright. Carboxylic acid is relatively a weak acid. Macam yang saya mention tadilah, carboxylic acid itu weak acid. However, it is stronger than phenol and alcohol. Okay, dia lebih kuat. Carboxylic acid ini adalah stronger acid than phenol and alcohol. Okay, so kalau dalam susunan macam ni lah, carboxylic acid, stronger acid compared to phenol, stronger acid compared to water, and stronger acid compared to alcohol. So, kalau kita lihat kat sini, alcohol lah the weakest acid. Alright. Kenapa? Kenapa carboxylic acid itu most acidic? So, kita lihat dari segi stability of ion form. Okay, selepas carboxylic acid, phenol and alcohol ini dissociate in water. So, kita lihat carboxylic acid, okay, selepas dissociate in water, akan form carboxylate ion. So, resonance structure lah, akan ada resonance structure. Sebab apa? Sebab negative charge on oxygen atom ini can be delocalized between two oxygen atoms. Alright. Okay, dan carboxylate ion ini stable sebab negative charge ni dia delocalized between two oxygen atoms. Compared to phenol. Phenol bila dissociate in water akan form phenoxide ion. Stable juga phenoxide ion ni sebab ada resonance structure juga. Negative charge on oxygen atom ini boleh delocalize over the benzene ring. Okay, tetapi carboxylate ion more stable compared to phenoxide ion. So that's why carboxylic acid more acidic compared to phenol. Okay, so macam mana pula dengan alkoxide ion? Okay, alkoxide ion ini less stable. So, alkoxide ion less stable. Alkoxide ion less stable compared to phenoxide, compared to carboxylate ion. Okay, kenapa? Okay, alkoxide ion ni dia less stable sebab okay, alkoxide ni dia ada R. R ni apa? R ialah alkyl group. Alkyl group. Okay, alkyl group ni peranan dia adalah EDG, electron donating group. So, bila ada EDG, okay, kita lihat kat sini, bila ada EDG group, ini EDG, so EDG group ni dia akan inductively increase the density of electron on oxygen atom. So, negative charge on oxygen atom ini jadi tinggilah sebab ada EDG ni. Okay, electron donating group. Jadi akan straighten, akan kuatkan ikatan OH bond. So, H plus difficult to be donated. Jadi, bila H plus susah nak donated to H2O, so maksudnya dissociation of alcohol in water ni jadi lemah lah. And formation of H3O plus itu rendah. Jadi, alcohol ini adalah weaker acid compared to phenol, compared to carboxylic acid. Alright. So, kita continue inductive effect. Okey, kita lihat inductive effect ada dua. Satu, kalau ada EWG group iaitu electron withdrawing group, dan satu lagi kalau ada electron donating group ataupun kita panggil EDG. Okey, EWG, kalau ada EWG bonded to carboxyl group, okey, kita lihat apakah yang akan berlaku. And electron withdrawing group ataupun deactivating group, okey, EWG adalah deactivators, okey, that attached to a carboxylate ion will delocalize the negative charge. will delocalize the negative charge, thereby stabilize the carboxylate ion and increase acidity. Okay, jadi ada EWG dia akan inductively attract the negative charge. Okay, menyebabkan carboxylate ion ni jadi stable lah. Okay, ada EWG, acidity of carboxylate acid meningkat. Okay, kalau ada EDG electron donating group. Okay, dia adalah activating group ataupun activators. It will destabilize the carboxylate ion and decrease acidity. Okay, kalau ada EDG akan inductively increase the negative charge on carboxylate ion. Okay, so ada EDG akan decrease acidity. Alright. The inductive effect, electron withdrawing group in the compound. Okay, siapa itu electron withdrawing group? Okay, contoh adalah nitro ataupun halogen seperti fluorine, chlorine, bromine, iodine. Okay, semua EWG group ni will reduce the electron density of OH. Okay, jadi bila density of electron dekat OH ni rendah, okay, thus OH become weaker. So OH bond ini become weaker and H plus can be easily released. Okay, the compound is said to be more acidic. Okay, sebab H plus senang nak release, jadi lebih berasid lah. Okay, so EWG increase the acidity. Alright. Okay, example. Okay, example kita ada ni apa ni? Ni ini adalah 2-chloro-propanoic acid ya. Okay, propanoic acid lah. Ni 1, 2, 3 carbon kan. So 3 carbon propanoic acid. Disebabkan ada chlorine at carbon number 2. So namanya 2-chloro-propanoic acid. And then kita ada satu lagi 1, 2, 3. So ini adalah propanoic acid. So kita nak compare di antara 2-chloropropanoic acid dengan propanoic acid ni. Siapa yang more acidic? Okay. So 2-chloropropanoic acid ada chlorine. Okay, ada chlorine. So chlorine ini adalah EWG group. Therefore, reduce the electron density of OH. Okay. Ini kan dia akan withdraw electron inductively. Okay, so akan weaken the OH bond. So H plus can be easily released. So acidity of 2-chloropropanoic acid more acidic compared to propanoic acid. Okay, boleh. So ingat, EWG group increase the acidity. Okay, the electronegativity of electron withdrawing group in the compound. Okay, sekarang kita lihat pula, kita ada ni ada fluorine. Okay, dekat carbon number 2 juga. Yang ini kita ada chlorine. So yang ni nama apa? Yang ini namanya 2-chloropropanoic acid. Yang ni pula 2-chloropropanoic acid. Okay, so sekarang ni dua-dua compound tu ada EWG group. Okay, dua-dua tu adalah EWG group ataupun kita panggil juga electron attracting group. Okay, but the electron negativity of fluorine are more than chlorine. Okay, lebih. Electronegative fluorine tu lebih daripada chlorine. Thus, the electron density of OH in CH ataupun in 2-fluoropropanoic acid is less. Okay, maksudnya fluorine ni akan withdraw elektron ni kuat daripada chlorine dalam 2-chloropropanoic acid. Okay, jadi OH bond kat sini, okay, dalam 2-fluoropropanoic acid ini weaker than in 2-chloropropanoic acid. Therefore, H plus in 2-fluoropropanoic acid easily donated. Okay, so acidity of 2-fluoropropanoic acid is higher than 2-chloropropanoic acid. Alright, and then kita lihat lagi. Okay, faktor yang ketiga ialah number of electron attracting group in the compound. Okay, tadi saya dah mention dah. Okay, electron attracting group ni sama seperti EWG group lah, electron withdrawing group. Okay, example. Okay, compound yang pertama ni kita ada 2 Cl. 2 klorin. So maksudnya ada 2 EWG group in this compound. Okay, while another compound ni hanya ada satu saja klorin. Maksudnya hanya ada satu je EWG group in this compound. Okay, this compound contain 2 Cl atoms that make the bond of OH weaker. Okay, then in compound 2-chloropropanoic acid which only 1 chlorine atom. Thus, H plus in this compound is easily donated. Okay, so compound ini become more acidic than 2-chloropropanoic acid lah sebab ada more EWG group. So lebih banyak EWG group, more acidic. Okay. And faktor yang keempat ialah position of electron attracting group. Okay, ini position. Position lah. Kita lihat. Okay, sekarang kita ada ini nama apa ni? Nama apa compound tu? Kita lihat Ini 1, 2, 3, 4. So compound itu adalah 2-chlorobutanoic acid. 4 carbon kan? Okay, yang ini pula 1, 2, 3, 4. So, position of chlorine ni dekat carbon number 4. So, yang ini 4-chlorobutanoic acid. So, di antara 2-chlorobutanoic acid and 4-chlorobutanoic acid ni, yang mana satu yang lebih berasid? Okay, kita lihat. The distance between chlorine atom and carboxyl group in 2-chlorobutanoic acid is nearer compared to in 4-chlorobutanoic acid. Okay. So, kalau lagi dekat tu maksudnya lagi kuatlah pengaruh EWG group tu. Okay. Akan attract elektron itu. Okay. Menyebabkan OH bond in carboxyl group tu lagi lemah lah. Okay. So, the OH bond in 2-chlorobutanoic acid is weaker than in 4-chlorobutanoic acid. So, H plus is easily donated. Okay, so acidity of 2-chlorobutanoic acid more acidic compared to 4-chlorobutanoic acid. Okay, so ingatlah kalau position lebih dekat dengan carboxyl group tu more acidic. Okay, position of apa? Position of EWG group. Okay. The inductive effect are dependent on distance. Okay. The effect of EWG group decrease as the substituent move further from, lagi jauh from the carboxyl. Okay, so kita lihat contoh ni Contoh kita ada compound yang pertama ni. Compound yang pertama ni 1, 2, 3, 4 So, chlorine ini dekat carbon number 4. Okay, compound yang kedua, chlorine ini dekat carbon number 3. Ini dekat carbon number 4. Ini carbon number 3. Okay, compound yang ketiga, okay, chlorine dekat carbon number 2. So, bila kita lihat kat sini, okay, ini nilai pKa. Kalau kita ingat pKa tinggi maksudnya Ka rendah. Kalau Ka rendah maksudnya itu adalah weaker acid lah. Weaker acid lah. Okay. Betul. Ka rendah maksudnya dissociation of H3O plus itu rendah lah. Jadi acid lemah lah kan. Okay. Jadi sekarang ni kita lihatlah bila pKa tinggi maksudnya ini asid lagi lemah lah ni. Okay, weaker acid. Okay. And then kalau kita lihat position ni EWG group dekat dengan carboxyl, pKa-nya rendah. pKa rendah maksudnya Ka dia tinggi. So, yang EWG dekat dengan carboxyl group okay, adalah stronger acid compared to carboxylic acid yang ada EWG group tapi position EWG group jauh daripada carboxyl group. Okay, so remember kalau pKa tinggi ni maksudnya weaker acid. Okay, so lihat kat sini lah. Okay, ini pKa rendah, stronger acid. Alright. Okay, faktor yang berikutnya, the inductive effect of electron releasing group ataupun electron donating group. Tadi kita discuss EWG, sekarang kita discuss EDG. Okay, EDG ni contohnya siapa? Contohnya alkyl group lah. Okay, example. Okay, example kita ada, compound yang pertama ni adalah ethanoic acid. Ada 2 carbon kan? So, ethanoic acid. Okay, compound yang kedua kita ada 3 karbon. So, ini adalah propanoic acid. Okay, so kita nak compare siapa yang lebih acidic. Okay, R ialah electron releasing group ataupun EDG lah. Okay, so the size of R group in propanoic acid is larger than in ethanoic acid. Betul lah, sebab yang ini ada 3 karbon kan. Ini EDG dia lebih besar lah. Okay, so CH3, CH2 is stronger releasing group. Okay, yang ini ni stronger ni kat sini lah daripada propanoic acid. Okay, ini EDG group lah ni. Is stronger releasing group than CH3. Okay, daripada CH3, EDG group in ethanoic acid. Okay, so the electron density of OH in CH3CH2COOH ataupun in propanoic acid increase. Okay, jadi macam ni lah bila ada EDG, so maksudnya dia akan inductively increase the density of electron in the OH bond. So H plus difficult to be donated. Okay, attraction di antara H plus dengan O negatif ni makin bertambah. So H plus difficult to be donated. So conclusion yang kita boleh buat ialah kalau ada EDG, the acidity of carboxylic acid will decrease. Okay, remember EDG reduce the acidity of carboxylic acid. Alright. So setakat itu sahajalah kuliah kita pada hari ini. Okey, jadi jangan lupa scan QR code itu untuk mengesahkan kehadiran anda. Okey, dan setakat itu sahaja kuliah kita. Assalamualaikum.